Okay, so this time I'm trying to record the audio and the video separately, so I I hope I can get rid of all the off-sync audio in the videos. So this video is about parallax mapping. How do we do that? Well, basically, we ray trace in our pixel shader. So what is the basic idea behind this? Let's say we have a surface like that maybe, and also we have the normal map already and all that stuff, but it doesn't look like it has depth, right? And we want to fix that because it just sucks. We want to be able to say, you see that? That's not a wall. And the way we do that is we think of where would we actually look at if it wasn't a flat surface. Like, let's say I'm looking from here to there. Then I know, okay, I'm looking at this point of my vertex, but normally what I would look at is this point. So because of that, I know I actually want this. I want the normal from here, and I want the texture coordinate from here. Now, how do we figure that out? The way I want to do it in the next video is what I will show you now, but the general idea is, okay, I know I've hit the surface here, which is the texture coordinate that was sampled and all that, but I can just step backwards. I have the normal, so I can figure out how high I get with every step. So I said light blue for normals, I guess. Yeah. So my normal is like this. Now I multiply my normal by this vector, and what I will get is maybe gray, and what I will get is this. Okay? This is the result if I calculate the dot product between both of the vectors. This length. And because of that length, I know, okay, if I make one step along my vector, I will get as high as this is long, as that is long. So I can like tilt it and I know, okay, I get that high. And at first I want to step out as far as I can. I know my height map can at most be of height 1 because it's sampled in a texture, so the highest value it can possibly be is 1. So I step back so far that the height of my view vector, or the line here, is I want to go to the point where the line is of height 1, because then I can be sure that I'm above the height map. So I step back until I'm like, let's say here. And now I can ray trace. I can say, okay, I know how long my steps are, I know how much the height changes. So what I do is first I go in steps. So let's say my next step is here, and then I test for this point, and I take the texture coordinate from here, like that, and then I see, okay, I am still above the height map. So I take the next point. I keep on stepping down, basically. So let's say here. So now I take this point. I still see, okay, I'm above my height map, everything's fine. So I do it again. I obviously I always have to take the value of the height map there. Then the next point I sample is maybe here. And I'm really, really, really close. But I'm still above the height map. So I take the next point, which is here. Like there. I guess I should mark the points. First is there, 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 and there. And now I know, at this point I know, okay, I'm below my height map and there I'm above my height map. So the actual point on the height map has to be somewhere in between these two. And then I can do binary search. So I start by checking at this point. And then I see, okay, I'm below my height map. I guess I will have to magnify this a bit and draw it somewhere else. So our height map is like that, except it's black. Remove. Okay. So height map. It's like that. And my view vector is like that. And I have tested, let's say there, and then here. Okay. And now, in my next step, I test here. And then I know, okay, I'm still below. So in the next step I search between these two. And then I get this one. This point. And I know, okay, now I'm still below. I search again between these two. I should remove that. I search again between these two. I get that point. And then I search again and I get that point. So from being pretty far off, at least at one side, I'm getting really, really close with just 1, 2, 3 steps. It's like if I went with steps like here, except 2 to the power of 3, which is 8 times. So if I had gone in steps which are an 1/8 of this area, I would have gotten the same result. And if I did one more step with binary search, I would get as good a result as if I had stepped with a 16th of the distance between these two, and so on. So I can get pretty accurate with very few steps of binary search. So now I know, okay, this is where I would actually hit the height map with my view vector. And then it's pretty straightforward. I just take the normal map or the normal from this point instead of that point, and the texture color from this point except for that point. And because I do that, it looks like there's actual depth to it. I wonder if I have a picture if I have a picture with that. Yeah, so here's a small comparison. This is just normal texturing. This is normal mapping. You can already see there's quite a difference. And this is parallax mapping. If you compare these two, it looks like it's coming out of the wall quite a bit. I have to say, the parallax mapping I implemented here is quite buggy. You can see when the angle is just a bit smaller than directly onto the surface, I get a lot of artifacts. But you can already see the general idea. I think I have a better picture of this. Maybe not. Let's see this one. Oh, I think it's Yeah, this looks better, right? You can see there's depth and all that. And I also did a point light. I will go about that in one of the next videos, I guess. Thanks for watching. That's all for now.